งและการทำโปสเตอร์ที่ใช้ในการนำเสนอค่ะประโยชน์ในการส่งออกในครั้งนี้นะคะได้มีการแลกเปลี่ยนความคิดในการทำโครงงานใหม่ๆกับเพื่อนชาวญี่ปุ่นและพัฒนาศักยภาพตนเองมากยิ่งขึ้นค่ะ
งานประชุมวิชาการนำเสนอโครงการวิทยาศาสตร์ของกลุ่มโรงเรียนวิทยาศาสตร์ของประเทศไทยและประเทศญี่ปุ่น 2015 Thailand Japan Student Science Fair 2015ซึ่งเป็นเวทีจัดแสดงผลงานเพื่อผลิตและพัฒนานักเรียนที่มีความสามารถด้านคณิตศาสตร์และวิทยาศาสตร์ในการสร้างความรู้และนวัตกรรมใหม่ๆเพื่อเป็นต้นแบบและกระตุ้นการพัฒนาคุณภาพการจัดการเรียนการสอนวิทยาศาสตร์และคณิตศาสตร์ให้มีประสิทธิภาพมากขึ้นต่อไป
The existence of the event intends to be carbon converse, which presents a carbon configuration, exchanges information, inspires, and develops its students to be researchers and inventors who are willing to turn climate innovations and better the economy of the country. Thailand's Student Science Fair 2023 focuses on the technology of speeding
(2023) or TJSSF 2023. My name is Wachirawan Aphinyanu-Rangsi.
And I am Valintana Suryawong.
We are students from Princess Chulaporn Sen High School, your moderators today. You are with us in Smart Classroom 2202, scheduled for the presentation under the theme of physics. We would like to welcome you all to the 13th project oral presentations. First of all, we would like to introduce our commentator. The first commentator is Assistant Professor Dr. Abhishek Tangtakan from Department of Physics, Faculty of Science, Khon Kaen University. And we Pimpabut from Department of Physics, Faculty of Science and Technology, Le Ratchapat University, as our second commentator. We are so glad to introduce 10 schools that will be enjoying this oral presentation in the morning. First, Princess Chulaporn Sen High School, Le. Raise your hand, please. Princess Chulaporn Sen High School, Buriram. Tokyo Gakukei University Senior High School, Tennoji High School Architecture, Osaka Kyogo University, Gamnerd with Science Academy School, National Institute of Technology Toyota College, Hiroshima University High School, Princess Chulaporn Sen High School Trang, National Institute of Technology Kosen Suroga College. Are you here? Princess Chulaporn Sen High School, Nakhon Si Thammarat. Today's session is being recorded for viewing as post-conference. Therefore, you can watch the recording later or live on TJSSF 2023 channel on YouTube. Of its presentations. The time for each presentation is 15 minutes. 1 minute for the preparations, 7 minutes for the presentations, 5 minutes for comments and discussions, 2 minutes for certificate and take a photo. Please check the time on this monitor. If we show this size, it means that you have 1 minute left. And if you see this size, it means you should stop because the time is up. At the end of the oral presentations, every presenter will receive a certificate of the presentations. During the presentation, please switch off your mobile phone if you want to take a photos. Then, please stay in your seat and refrain from walking around. Be mindful of the audience. The presentation will be start at 9:30 a.m. At this moment, please feel relaxed. Toilets are on the left and the right side of second floor. For additional information, today you will receive only a cover of certificate, and you can download the certificate on the TJSSF 2023 website later. We apologize for your inconvenience. Ladies and gentlemen, without further ado, this is my pleasure to welcome our first group from Princess Chulaporn Science High School. Today, he is going to present his project entitled the ESP-based dust and carbon monoxide detectors for exhaust emissions. Ladies and gentlemen, I will now turn the session over to our presenter. Please give them a round of applause.
On behalf of the Princess Chulaporn Science High School, I am so welcome to you to come this today. My name is Apanya Nenut. I am the projects. This is my project. This is electrostatic particle-based dark and carbon monoxide detector for the enhanced emissions. And in the first of my presentations, I will talk about the introductions. My introduction, that's what I want you to look around in the 1 year before. In the all regions of the Thailand have some of the pollutions of the PM2.5, and it is so effectively to the health of some people. That's what important of my life. She is my mother who have the respiratory sickness from the pollutions. And from the researching, I found that the main cause of the pollutions is the personal vehicles. And I think I want to invent the innovations to detect and detox of the enhanced emissions to reduce or reduce the carbon monoxide and the PM2.5 from the enhanced emissions. This is my objective of my project. The first of my objectives is to make the new innovative solutions. To develop the innovative solutions and reduce the carbon monoxide emissions from the vehicle enhance. And the fix the global warming, I want in the long term is can to the fix of the pollutions and is the reduction of the cost of carbon dioxide is the main cause of the greenhouse effects. And the last of my objective is the new design of the enhanced bikes. I think its innovation can to be the next way to be the new design of the enhanced emissions. My researching methodology, in the first I am design and contractions. Design contractions of small scale of the ducts of the complex of small emissions from the enhanced emissions. In duct 3, we have electrostatic particle, but it's so large. And I want to fix it in the smallest to fix in the enhanced emissions. And the part 2 is a testing from the passback transformer voltage. And the testing passback voltage is during the testing from. This is the part. I want to know what is the best of way to what the kilovolts that I want to use in my projects. And this frequency range of the 6 kilohertz. And this is my blueprints and circuits and prototypes. This is my first blueprints to have, and the first project I start with it. Can I explain this? In the rest part is a discharge wire, and electroparticle is using to you get to the choosing the negative ion to this duct, and it collects in the molecules, and in the green, in the blue part is the collecting phase, that is electrostatic. When it's a negative ion, formed to the collect in the collecting phase, and this collecting phase is can easy to bear and the cleanings, and you can using it again. This is my experiments to collect in the formations. I use it into the DC voltage in the high voltage transformer to get, and I use the modest FET to the switch of the Kirkus and the post generations to get from the informations. And to collect the informations, I use to the sensor of /XMQ2. I use the sensor to collect the carbon monoxide informations. And this is my prototype to be used in this testing. My results of my projects is in the table 1. In the table 1 is formed to the results of the carbon monoxide consensus mu-sinister testing using the prototypes. This is what is my sensor can read it. And this have some error in the RPM. RPM is a round per minute of the engines of the car. And I can reading from in the 5,000 into the 2 in the 6 and the 8 kilovolt to reading of my sensor. And the next table is all of my results. In the effects of the particle dispositions. In this table, that's it to tell you how it can work. The average of overall efficiency from this testing is 64.3, and from the simulation software is 72.7. But this is a weak point of my project. In the now, it can use in the wrong time durations. And you see that in the 10 minutes, 20 minutes, and 30 minutes, it can the overall effective that water rolls by the time. Is effectively on the particle of separation either before using the prototypes and after using the prototypes. It can reduce the content of the carbon monoxide gas and some of the particle on propulsion is the 20% of the normal emission concentrations. That's my summary. The average particle as the portion is efficiency is 64.3%, and the testing results is driven by the enhanced gas purifications device design. And I think this is my project is can to help the most of people who with the weakness like my mom's, and I want to see the clear sky scan and have some of the recommendations of this project is have to use more of the high voltage components and extreme esteem considering construction and testing to prevent protein hazards. It is critical to the Polystyrene Safety Museum to test and proteins rise the main arrays. And this is all of this my projects, and thank you to your kind attention for everyone in this room.
Have anyone have any questions? Okay. Next, may I invite our commentator to give some comment to the presenter, please?
Okay. Could you explain about the ESP working? Why it can collect the carbon monoxide?
That's it, in the electrostatic particle. How it's working is that is the two parts in the important. Is the first part is a discharge Y. Discharge Y is how to electrolyze in the air, and we have a spark gap, and they get the negative ion to the molecules of the dust and carbon monoxide. And the blue part is we get the electric to make the electric magnetics. To when is the negative ion collect the dust and will to send it to the collecting dust with magnetic fields.
Can we use the positive ion to collect the dust?
I think it's easy to using the negative ion. This is when you electrolyze in the air, it will get to the more than negative ions more than the positive ions, and it's easy to use the negative ions.
In this case, will there be ozone gas generated from your device?
Can you tell
The ozone gas.
ozone gas.
Normally, under the high voltage, maybe there's some ozone.
In this my experiments, I don't in my testing I'm done thinking for the ozone gas, but in the next time and into the April of this project I will to the collects of the some of to use to in the environmental. And I think it's thank you to you to approve my projects.
I would like to know about the gas out from the exhaust tube on the vehicle. This device can collect the carbon dioxide too.
Yes, this device can collect things of or when what can I tell you what is I use to the ESP? I think is now is the enhance of technology. It can to the detecting from the 10 p.m. This for is the blast of the PMs. And I use the ESP because it can you detecting from the 0.1 p.m. It can to the cast of the molecule with the electron. In the everything is through this the enhanced tube. It can to cast with the negative ion.
During the measurement, there should be some error occur. What should that be, and how you're going to solve it?
My error, I can solve it. I think is my error was approved. For appears. The air cruise is so very fast, and this of my device. It can be to the cast in the ion with very fast in this the enhanced tubes.
One more question. In the abstract, you mentioned about the voltage you used is are 10, 15, and 20, but over here it changed.
I'm not using this that table in these presentations. You can see in my poster, and I forgot from these presentations.
Are there any questions from the audiences? The question can be based on the number that he presented. Some number you may question where they come from. Is it reliable during the measurement? This is some basic question you can ask.
Feel free to interrupt me. If there anything you want, you can question me now.
Attack the number first. That's the easiest question.
Okay, thank you, the commentator, and may I invite Assistant Professor Dr. Abhishek Tatakan to award the certificate to the presenter from Princess Chulaporn Science High School, please. Then the next presenter are from Princess Chulaporn Science High School Buriram with the project entitled Development of a Rubber Density Analyzer. Please welcome.
Good morning, everyone. Hello, my name is Thanyathorn Yopawin, and this is Natapon Bapan. We are from Vincent Chulaporn Science High School Buriram. We are the developer of development of rubber density analyzers.
Introduction. Rubber is an important economic span of Thailand. Rubber has been exported to another countries so much, and when farmers want to selling liquid rubber, before selling, farmers must check the quality of the rubber. But in the present, farmer cannot check the quality of the rubber. Because of this, it is inspired to create this project. When design is under the condition this easy to use, comfortable, no method complex, use little time, analysis calculate, and low price. Our solution overview. The problem standard percent rubber contains ISO 126 1995 have drawbacks, long time measuring process, toxic exposure to chemical agents, destructive methods complex, high energy consumption, use many devices and expensive costs. The condition needs a measuring device with easy and user-friendly, high accuracy, non-destructive measuring method, non-toxic, low energy consumption, less cost, and durable. The objective: produce the rubber density analyzer and compare performance in analyzing the density of the developed density and analyzer compare to the commercially available standard density meter. Next, and literature review. Nibis Bunpirom and team conduct. Sorry. Again, please. Literature review. Nibis Bunpirom and team conducted research and on the quality of the digital latex. The research showed that the use of digital quality of latex can solve the problem of latex quality with standards of 16.4%. And the method. Part 1, pilot experiment. Part 2, design and construction of the analyzer. Part 3, performance testing and bug fix procedure of the analyzer. Part 4 Comparison of the density measurement performance of the analyzer with the general standard used in the analysis of density of rubble. And Part 5 Calculate the price of analyzer.
And the result. Part 1. We conduct an experiment according to hypothesis. From the study, it was found that density have correlate with percent diaper contest. And part 2. We have found many problems and fixed them by model 1. Problem are the test tube base is too big and the test tube log arm is too tight. Make analyzer cannot process. And extract first found the same problem. And the test tube base is too big and the test tube log arm is too tight. Make analyzer cannot process. And extract seconds. We use bigger instead test tubes. But we found a problem the bigger is too big and heavy. It make analyzer inaccurate. Adjusters, we adjust every problem and develop to model 2. By use acrylic instead, the filaments form durable and less cost. And the analyzer works by found density of liquid rubber and process is 2% dye rubber contest. And part 3. From the study, it was found that the correlation between the weight and the effective test tube that were read out of all 6 test tubes and used to create a calibration curve. The equation of weight is 11.1x minus 75.8 and had a value of r squared is 1. And the correlatives between the volume and average water of the 6 test tubes and had a value of r squared is 0.999. And the graph showing the correlation between weight and volume of water. And the next graph is the data from analysis before bug fix. And this graph show about correlation between percent dye rubber content and the densities. And if the density is low, percent dye rubber content will be high. And this part 5 and calculates the price. These are circuits inside the analyzers. Total is 428 baht. And this video demonstration. Connect the analyzer to program Arduino IDE in the computer. And step 2, put a sample into the test tubes. And step 3, pass S bottle in the program and pass enter bottle. Step 4, please wait 30 seconds. And then step 5, computer will show you data about density of rubber and percent dye rubber content. Thank you for
Excellent presentations. Have anyone have any questions? Okay, next, may I invite our commentator to give some comments to the presenter, please?
Okay, could you tell me about the mechanism of the your device? Why it can measure density?
Okay. My analyzer is made with two sensors. It's a low cell sensor and ultrasonic sensor. And low cell sensor can read the weight of the mass, yes, and mass of the rubber, liquid rubber. And then the ultrasonic will find the height of liquid rubber and proceed to the volume. And we use mass and volume to proceed to density of rubber.
Okay, you receive the density of the rubber
Yeah.
by this process.
Yes.
Okay. And how to calculate the percentage of the dry rubber on this result?
We create a calibration of standard graph of the between density and percent dye rubber content and process in Arduino board in program Arduino IDE on the computer.
By varying the density?
Yes, yes.
It's like you dry up the liquid rubber and weigh the dry rubber content.
Yes.
So you use the same liquid rubber and heat it up.
Yes, yes.
Okay.
How long the time of this process?
30 seconds.
In the heating.
In the heating, use 16 to 20 hours. In the standard method is ISO 1995. Is it a complex method and use many devices?
This is an interesting project, one of the interesting projects. If you want to commercialize it, what is your advertisement regarding what is new here? You will say that it's cheap, right? And
Yes.
what about what is new?
Is a new way to find the percent DRCs, percent dye rubber content.
Isn't there any commercialized device available on the market?
No. This in the market is used. In the market, did not use density of rubbers. In the market, we use about in the market. This is not young. This is not the density.
Thank you, the commentator. And may I invite Assistant Professor Dr. Nawat Pimpabut to award the certificate to the presenter from Princess Chulaphorn Science High School, Buriram.
So since we have about 1 minute left, I have some suggestion. In this case, we're going to measure the density, right? You can also put just simple equation, rho equals to m over v. You should, you can mention that we're going to measure the mass with this sensor, right? And
In the ISO, we use weight.
the weight, yeah. Yep. So my comment is, you can add the simple equation wherever it has, even though it is just simple one. Mhm.
The next presenter are from Tokyo Gakugei University Senior High School with the project entitled Creating Dark Shield from Microgravity Experiments. Please welcome.
Hello everyone, I'm Yuka Inoue, one of the members of microgravity experiment team of Tokyo Gakugei University Senior High School. Our research topic is creating dark shield for microgravity experiment. Okay. I talk about the following items. First, I would like to talk about what kind of activities we usually do. Our concept is, let's make space more comfortable. As living in space is no longer a dream, it is now important for the people in space to live in a more comfortable environment. Therefore, in order to make future life in space more comfortable, experiments must be related to daily lives. In this work, we put the objects in the box and drop them. Then, I'll talk about method of microgravity experiment. When a camera and an object are dropped together, the inertial force and gravity balance, creating a state of microgravity. Next, then I talk about pre-research. The experiment is, I conducted the experiment by placing an experimental body in cardboard box, but there is a problem. In microgravity experiments using Dove Tower, when a microgravity experiment is created for an extended period of time, the air resistance force increases and the gravitational accelerations of the capsule becomes related more. In addition, public flights are impractical because of the enormous cost involved. We need an experiment system that is low cost, high precision microgravity experiments. For this purpose, we created dark shield. Next, dark shield design. Wire guides and hanging wires were used to eliminate as much buffering as possible when falling from the third floor of our school. An LM guide is a machine relevant component that works to move a heavy object lightly and straightly by applying beginnings that achieve rational motion. In this study, the inner capsule was installed in the black shield so that it moves only in the direction parallel to the black shield. In addition, a suction cap at the bottom was installed to hold the inner capsule, which is caught in the dark shield during the fall. together with the black suit. Lower L parts, we call it Hagukun, to TG-DS1 when dropped, a shock-absorbing material was attached to the bottom of the capsule. Forward mortality and buffer cushioning material were used as shock absorbers. To increase the direction of the microgravity experiment, it is necessary to increase the time that is isolated of the capsule can move freely within the black suit. Therefore, we attached the lower L parts. Here is a slide of the experimental method. Lastly, I talk about results. The figure 5 to figure 8 show that the rate of change in acceleration was smaller for the inner capsule than for the black suit for both TG-DS0 and TG-DS1. The magnitude acceleration was also longer for the inner capsule than for the black suit. This indicates that the dual selection of TG-DS1 improves G quality. However, the G quality of the capsule is higher than that of TG-DS1 because the weighted cardboard box is closer to the gravitational acceleration, the TG-DS1. The reason of the smaller acceleration in TG-DS1 is a friction of the LM guide. So, method for LM guide will be investigated in the future. References were listed below. Thank you for attention.
Thank you for the excellent presentations. Does anyone have any questions? Okay, next, may I invite our commentator to give some comment to the presenter, please?
Okay, I have two questions. The first, what the gravitational acceleration of the Japan?
Could you please repeat your question one more time?
What is the acceleration of gravitational force on the Japan? Okay. So the second, how to reduce your retarded force from the air in your experiment? How to reduce the retarded force, drag force from the air on your experiment. If you drop,
I see. We used to use cardboard for experiment, but by this method, we have to make again and again when we dropped from the third floor. So we created this one in order to reduce in order to increase air resistance, and also use this structure again and again for experiment. Yeah.
Do you think your result data is good enough to make conclusion out of them? Because it's like the data kind of scatter. Is there a trend in the result?
This result suggests that increasing air resistance, but this is the black seed. When the black seed has done falling, the black seed was bounded. So this plot is still scattered. I think. Yeah.
What is the meaning of microgravity? In the case that nobody or somebody doesn't understand it.
We won't make course to zero gravity, but it is difficult. So in order to course lead to zero gravity,
Micro is pretty small, so we should say we're gonna make a macro gravity.
No stress for gravity. So, for example, I dropped a pen in microgravity. It is and a pen would be fly kind of like.
Questions from audiences are important too. We have to come up with some questions even though we maybe have a minimal understanding of that project. But you should be able to ask one question, okay? Questions? Any? Okay. Just one. Quick one.
Can you explain how to work your experiment?
Our project. You mean I explain our project? Okay. We usually put objects in the box and loft from the third floor, in order to we can see movement of in the microgravity. Yeah. So, for example, we put candle with fire and following the fall, the shape of the fire is round, and just like we object, yeah. Thank you for your
Okay.
question.
Thank you, the commentator and the audience. Next, may I invite Assistant Professor Dr. Abhishek Tangakan to award the certificate to the presenter from Tokyo Gakugei University Senior High School. The next presenter are from Tennoji High School, Agtech 2, Osaka Kyoto University, with the project entitled Exploration of Artificial Snow Productions. Please welcome.
Hello everyone. We are from Tennoji High School attached to Osaka Kyoto University. My name is Makoto Saokar. This is Ari Inoue. Our project name is Exploration of Artificial Snow Production. First, we will talk about introduction. Many researchers have developed many kinds of artificial snow generators. For example, first picture is Nakaya type artificial snow generator. Dr. Nakaya created an artificial snow generator for the first time in the world. But it requires a low temperature room, so it costs a lot. And the second picture is Hiramata type artificial snow generator. It is easy to make, but difficult to set conditions such as temperature and humidity. But they are very important factors determine the shape of snow crystals. Based on these problems, Murai type artificial snow generators was created. Peltier elements were used. It is semiconductor, some electric device that cool on one side and overheat on the other side when current is applied. However, we found some problems. That advanced cameras are required to photograph snow crystals, and the temperature control of Peltier elements too difficult. Peltier elements require special skill from last study. So we thought there are some problems in the artificial snow generators exist. From these problems, our study objective to create a system generating artificial snow using a small deep freezer that can change temperature and humidity conditions and doesn't require relatively large equipment compared to conventional system. Next is about the method. We created 4 kinds of generators while improving and did 4 types of experiments, 1A, 1B, 2A, and 2B. We discriminated the snow crystals. A small steamer or heating wire were used to generate a fine mist in a cylinder in a deep freezer. and the steam cooled it as a move upward, and a crystal sprue was also attached to the top.
And this is a figure of snow generator we used in experiment 1A and 1B. And the steam from the steamer goes up and cooled. There is a lid on the top, and air circulation was generated in this cylinder. And in experiment 1A and 1B, we changed some materials and did experiments. Look at this table. In detail, the materials of cylinder, lid, and crystal support were changed. In experiment 1A, the lid and cylinder were used plastic bottle, and the crystal support was used cat's hair. And in experiment 1B, the cylinder and lid were used aluminum plate, and crystal support was used hemp thread. And this is a picture of cat's hair, and that is a picture of hemp thread. The reason we changed the crystal support from cat's hair to hemp thread is cat's hair was too thin to observe to take the snow crystal photo, and so we use this in experiment 1B. We use this hemp thread because it is very thick. And in experiment 2A, the generator was changed some points. This is a figure the snow generator we used in experiment 2A. And to slow down the temperature change in the inside the freezer, the freezer was surrounded by the styrofoam. And in addition to improve the efficiency of air circulation, the aluminum plate were attached over the styrofoam. And the illumination of the lid, there is a hole, so drilling holes also were tried to be improved the efficiency of air circulation. And in experiment 2B, the small steamer, this is a small steamer, and was changed to a heating wire and connected the power supply at voltage 10 volt. And this is the result. In experiment 1A, a pile of crystal of major category P, plain crystal group, and the crystal with cloud grains of major category R, limb snow crystals were observed. And in experiment 1B, this, in addition to the limb snow crystal group, this flat ice crystal of small category G2A were observed. And in experiment 2A, these limb snow crystal and ice crystals were observed. But in experiment 2B, the snow crystals couldn't created because the temperature in the freezer was too high to create the snow crystals because of the heating wire. In addition, the experiment time in experiment 2A was shorter than experiment 1A and 1B. In conclusion, 3 types of snow crystals in the global classification were generated, and we think the best system to achieve our objective is the generator we used in experiment 2A. Thank you for listening. Thank you for the innovative presentations. Does anyone have any questions? Okay, next. Okay.
I remember that in your presentation about Mirai model, you told us that you need at in
camera.
the video, but I don't understand what is the function of the camera for the snow production.
So, before in Mirai type of snow generator, this one, in this study, the camera of the expensive one was used, but we can't use it because we can't use it, and it is very difficult to set the pint. So it is difficult to take the snow crystal to clearly. Yes. So at first we used the smartphone with magnify glass. We used it, but when we taking the photo of crystals, the snow crystal was melted. So we changed the way to take the pictures, and we used in USB microscope. So we can take photo with keep distance. So we use the USB microscope.
Anyone else? Okay.
Sorry, one more time, please. In experiment 2B, we used the heating wire, and because the steam from heating wire is more smaller than the steam from the small steamer. So heating wire is better to clear the snow crystals. So we wanted to clear the snow crystals with heating wire because the snow crystals by using heating wire is very clear. Never tried.
When we heat the steam,
yes.
Okay, to set up the heating temperature. If you heat at the higher temperature, what do you think it would happen to your crystal size?
Crystal size.
If your steam is
Hotter. Yes. Crystal size. We couldn't clear the snow crystals when we use the heating wire, and the steam when steam is hotter. The temperature in the freezer was too high to clear the snow crystals, so now we can't create the snow crystals with hot steam. Thank you.
One question, please. Why do you have to study the growth of snow on the cat hair? What's the use of it?
Cat hair. In Mirai type snow generator, the rabbit hair was used, and normally rabbit hair and cat's hair and dog hair was used because the surface of
cat's hair and rabbit hair was not smooth, so it is easy to create the snow crystals.
Okay, thank you, the commentator and the audience. Next, may I invite Assistant Professor Dr. Apishok Tantakan. Oh, sorry.
The next presenter are from Kamnert with Science Academy School with the project entitled Investigation of Styrofoam Ball Stability in Acoustic Field. Please welcome.
Hello everyone, my name is Pacharakan Isara Yangun and this is Thanagrit Dawood. We come from Kamnert Vidya Science Academy and today we are going to present our project Investigation of Styrofoam Ball Stability in Acoustic Field. So first let's start with some introduction to our project. Have you ever heard of the word levitation? What does this mean? Levitation is the act of causing something to rise or hover in the air. You may have heard of this word in the animation or in the movie that we can cause an object to levitate. But do you know that in our real life, acoustic levitation can cause an object to levitate as well. So acoustic levitation is the act of suspending object mid-air by using sound waves. So how can this occur? So acoustic levitation use a standing wave which can create from the wave that travel into opposite direction and toward each other, and this can create a standing wave which can cause a different pressure and potential, and this can create a force that can go against the gravitational force, and it can cause the object to be trapped at mid-air. So acoustic levitation can be used in many applications. For example, by manipulating the liquid sample mid-air, or maybe contactless transportation. However, in the previous study, when we talk about acoustic levitation, we usually use like many of the transducer. So transducer here is the source of the sound wave. So we use a number of transducers because it ensures the stability of the acoustic field. However, in our project, we have conducted an experiment which only used the transducer of two transducers above and below, and we found that we can actually trap the styrofoam ball mid-air. However, when there is some external disturbance or force, such as the wind or maybe the reflector, the styrofoam ball can escape from the levitation very easy. So there is another experiment about the silicone drop oil drop experiment that is about a small silicone droplet walking randomly on the vibrating bath. And in this experiment, the behavior of the silicone oil droplet, which is a macroscopic object, can create the behavior that are similar to the that of the quantum. For example, the double slit experiment or quantum tunneling. And this later lead us to some question whether the styrofoam ball, which is also a macroscopic object and trapped inside the acoustic field, can exhibit quantum behavior that are similar to that of the silicon oil droplet and escape from the field even though there is no external force. And this is our research objects. So we want to investigate the condition that can cause the styrofoam ball to be stable under disturbance, both in classical and quantum mechanics. And here is our methodology. So first, we will simulate the potential energy of the system. And here we use COMSOL multiphysics to create the acoustic pressure of the field and use the MATLAB to create the potential energy of the field. Then we will conduct the experiment. And here is our experimental setup. So here we will have the styrofoam ball in the transducer setup. So it will levitate, and we will also apply the external force as the vibration generator, and we can vary the frequency of the vibration. Then we will predict the behavior of the ball and calculate the probability that quantum tunneling may occur, and also analyze and compare the results and find the condition that can cause the ball to be stable. And here's our theories. So we will use the acoustic pressure equation to find the pressure, and then use the Gokhov potential to calculate the potential energy of the system, so we can find the radiation force on the particle.
So, and next class is our results. So this is the pressure fields, and this is the potential field from our simulation. You can see from here the blue regions is the area with the lower potential, while the yellow one here is where is the higher potential. So the ball will be trapped in the area with the lower potential. So we can see that there are 4 trapping locations here, and our simulation can show the accurate locations where the ball will be trapped. So as we insert the force in the axial in a vertical direction, so we mainly consider the potential along this. And so first we consider this as a simple spring mass system. But when we track the displacements of the styrofoam ball over time, we can observe that there is not only one frequency can be observed. There are also like another overtone here. So such that we added the term of the nonlinear or the beta x power 3 here. Or this is called the Duffing equation, where the parameter alpha and beta can be calculated from the curve fitting. Then we can use this equation to predict the amplitude of the frequency response here. And this is our result here. So the parameter alpha and beta for the second wave and the third wave is the same due to its symmetry. And we can see that since the beta is a negative, we can see that the peak of the graph deviates to the left side here. This is called the subtopping effect. And we can see that there are some range of the frequencies that can exhibit more than one amplitude response. So, and furthermore, since like normally we only exert force in the vertical direction, but in the bicycle zone, there are like as motion can be observed here. Like normally it is only oscillate in the vertical direction, but there are but the chaotic motion can be observed here. And then when we analyze this, we found that like there's when the motion transforms from the first one to the second here, the amplitudes in the vertical direction decrease while the radial direction increase. So we can conclude that the energy transfer is occur. And on the other hand, we also consider this using the quantum physics, where there is the ball couldn't stay in the wave forever, even though there's without any disturbance. Like so as there is like a small section here, so we assume that the ball will behave like the quantum in a quantum harmonic oscillator here, and then we can calculate the probability that tunneling will occur. But in our system, the n is larger than can we calculate it directly. So we use the asymptotic formula to calculate it here. And finally, we can calculate the resident time or the maximum time that the ball could stay in the well before the tunneling will occur. And lastly is our conclusion. So our system exhibits the non-linear behavior and fit well with the Dolphin equation, and we found that the energy transfer from the vertical axis to the axial axis, this is cause the ball to escape from the system, and we use the biseable range is to determine the stability of our acoustic system here. And lastly, from that we calculate by in the quantum, we found that there is less significant that the tunneling will be occur. And this is our reference. So thank you for your attention.
Okay, thank you for excellent presentations. Does anyone have any questions? Okay, may I invite our commentator to give some question to the presenter, please? Okay.
It's okay. I don't need to use it. Okay. For quantum tunneling, you mean you would have to have the quantum well, which the tunneling probability depends on the depth of the quantum well, which means the potential you have to be realized, the potential of the well. But how do you translate your actual problem, which is the transducer, and engrave all the styrofoam? How do you translate this into the depth of the potential well in your quantum well calculation?
It's just only a simple model that so if that if with it's like not the it's unsure about the
So here we just calculate from the simple model, which we will not consider that much about the width of the potential barrier. So we just calculate from the probability that in one collision of the oscillation of the ball to the potential, how much probability is possibility of the ball to escape in one collision. So here we just consider a simple model, but it can be developed further if we would like to consider the width of the potential well as well. Yeah.
Yes, I think this is very important because if you have an infinite potential well, it will not be possible to tunnel at all.
Yes.
So that depends on the depth of your potential.
Yes.
Okay.
Thank you. So in your classical model analysis of the phenomena, you explained that there is a horizontal oscillation, like a minor horizontal oscillation within the object. How would you know or isolate the experiment so that that isn't what is the result of a chaotic behavior of the system? Not the actually it is shaking in a in your experiment, but could it be that it is a chaotic behavior of the surrounding environment that is happening and you just observed some chaotic behavior?
Okay, so from our result, we found that in one frequency, they can exhibit both behavior in the same environment. So, for example, at first, the ball may oscillate in the vertical direction. However, after some time pass, we can also observe the horizontal oscillation as well, and it is significantly affect the behavior of the ball. So it's not just a small oscillation, but the oscillation goes in triangular shape, and it can be easily observed. So we can be sure that it is not affected from the environment or the surrounding, as well as we ensure that the environment for both systems is the same.
So for the normal disturbance it shouldn't exhibit that long. It will exhibit around 1 second and this will disappear. But we can observe this for around 4 or 5 seconds of this chaotic motion. So we can maybe consider this as a coupling oscillation is occur.
Okay, quick comment. This group presenters are good at presenting, so the energy is very good, and they presented a good layout of introduction. It will be even better with the reference in your introduction too. Okay. Okay, time for the photo.
Okay, please welcome to get a certificate.
The fusion of earthquake proves contraction and Thailand tradition still house. Please welcome.
And hello, I'm Yuna Goto. I'm a student at Toyota National College of Technology, and my friend Kari is not here, so she will participate via video call. So I recorded her voice and we'll play that.
Today we are going to present to you about our project, the fusion of earthquake-proof construction in Thailand's traditional stilt house. We study about architecture at Toyota National College of Technology. We started this project because there was a big earthquake in Japan in 2011. We saw many videos of buildings collapsing, but I think a house is a place where you should feel safe in. So we wanted to make a simple yet strong structure so that people around the world could feel safe in their homes. Well, I'm going to start off with the problem. At the present time, Japan is known as a country with many earthquakes. But how about Thailand? As a result, strong earthquakes weren't observed in the central part of Thailand, but some were observed in the north and west regions. The purpose of this research is to make a new seismic structure that can be done with our knowledge. So we did a simple experiment. Now, I will show you the model we used for our experiment. First, using styrene board to make 150 millimeter framework cubes. Each bottom of the rod will be 5 millimeters square. Second, add rods on two opposite sides. Third, add rods on the top and bottom surfaces. Here, the base of the model is completed. Then we will add rods to the two remaining sides, but with different conditions. The limit length for the rod to be used are up to 300 millimeters long. By experimenting with different conditions, we can find out which structure is the best. Next, I will describe the experimental method. First, fix the bottom of the model to the floor. Second, take a thick strap with hooks on each end. Attach the center of the strap to the top of the model by using a clip. Third, hook on both ends of the strap to the measuring instrument. Finally, apply a force of 0.5 newtons at each time by pulling the instrument. Then, measure how many distance the model moved. In this case, we will use the maximum value appeared on the measuring instrument.
So the result of experiment showed that there are two types of earthquake proof contraction. Look at the left picture. A model 1, 2, 3, and 6 are strain-resistant type structure. A model 4 and 5 are ductile-resistant type structure. I will introduce a characteristic of these types. Strain-resistant structure has a high seismic performance when the bricks were placed in compression against horizontal force. In addition, strength is increased by inserting triangular pillars at both ends of the brace. So in ductile-resistant type structure, horizontal members absorb more energy than vertical members. So in conclusion, the following two things can be said from these results. First, the strain-resistant type structure is good at the power to withstand shaking. Second, the ductile-resistant type structure is good at the absorbing shaking. So for this reason, these two structures is important for building strong earthquake-proof construction. So we use the knowledge obtained from our experiment to come up with the idea of Stilt House, the fusion Japanese technology. The strain-resistant type of structure was used between the first floor and sticks into the ground. The ductile-resistant type of structure and strain-resistant type of structure was operated to the wall. So that brings us end of our presentation. Thank you for your listening.
Thank you for the excellent presentation. Does anyone have any question? And now may I invite our commentator to give some comment and suggestion to the presenter, please.
Did you attempt any kind of simulation with a software to verify your result, such as finite element software, doing the simulation in the computer?
Sorry, I'm pretty sorry.
Only experiment? Did you try to contact the university professor to do simulation with the software? Simulation in the computer? But that's an extra work. I suggest you should use computer to prove that.
So we don't have enough time. So we do.
Maybe for the next generation, with professor in the university's help. You need a high-end software to do it. But it's very good at predicting the relationship between the structure and the vibration too. This work is very good. It has high impact factor. Good work. As it's a fusion between Thai structure and your knowledge. It's very interesting.
Oh, thank you.
Do you think it costs a lot more to add your structures? What's the cost?
What's the cost? Sorry, I don't know.
Do you have to add many stilts in? Do you have to add many boots in the structure? For this one, how many boots do we have to add, and how much are there?
Maybe. Maybe it used 100 words, maybe so.
Okay, let me see the absorption energy graph on your experiment.
Without a graph?
Absorption energy graph. The graph, the result. Okay. How to measure the absorption energy of the experiment?
Sorry, excuse me.
How to measure the absorption energy?
And this says on Newton. So, and this is area and Newton fusion, and this is the area, and so
So normally it is an area underneath the curve, right? You have a curve, the mm and Newton as an axis, and then you get an area from that. And you should add the unit on the y-axis too, the unit of the absorbed energy. Since it is an area, it should be Newton millimeter. Yeah. You forgot to add the unit on the y-axis.
So?
The unit. There's no unit, so I don't know. It is 20 watt. It is 40 watt, right?
Yeah.
Okay.
Does anyone have any question?
Thank you, the commentator. And may I invite Assistant Professor Dr. Nuwat Pimpabut to award the certificate to the presenter from National Institute of Technology, Toyota College. So now everyone can get the snack box in front of 2201 room, the right side of the presentation room. We will start in 1 minute. The next presenter are from Hiroshima University High School with the project entitled The Best Earthquake Resistant Structure from Building Using Bamboo Structure.
Konnichiwa, sawadee-ka. My name is Tomohiro Ogawa. This is Shinichiro Yajima. Let's start the presentation. Our theme is applying the structure of bamboo to earthquake-resistant buildings. I'll talk about bamboo structure. The widths of the bamboo node are narrower near the ground and wider in the middle and narrower again at the height. This structure makes bamboo strong against the wind. So we thought apply this structure to the story structure of buildings. In other words, we can make more earthquake-resistant buildings by adjusting the vertical width of the floor to floor. The final goal of our research is to make the best the best story structure of buildings in terms of earthquake resistance.
Okay, I talk about the experiment. The purpose of this experiment is to investigate which type of story structure is best for earthquake resistance. The material for this experiment is a shaker table which we made, building a model of a building whose story structures can be changed, a slow motion camera, and a force sensor. These are the methods. First, shake the model with the shaker table and record it with a slow motion camera. Next, take the scene where the model shakes the most. In other words, the scene of the maximum displacement of the top floor. Finally, attach the force sensor to the center of each floor with threads. Then, pull each floor and reproduce the scene where the model shakes the most and correct the value of the force sensor. We conducted this experiment using 5 different models. One in which all floors are equally spaced. One in which the middle portion is wider. One in which the middle portion is narrower. One in which the area below gets progressively narrower. And one in which the area above gets progressively narrower. We have calculated the load on each story using the bending moment with each center point of the pole at each story. For example, to calculate the bending moment of this point, we add F4 multiplied by A, F3 multiplied by B, and F2 multiplied by C. The bending moment means the bending stress. It is directly connected to braking. So we concluded that it would be appropriate to take the bending moment at the road.
I'll tell you the results and discussion. This is the graph of the values of moment of each floor to that of the moment of the first story. You can see that there is a considerable variation in the bending moment values, and we think this is due to the difference of natural frequencies. So we cannot compare them in terms of bending moment values. So we think the ratio of moment of each floor to that of first floor. This is a graph. A building has the most load on the lowest floor when earthquake happens. So we thought, how much can we distribute the load to the second and third and fourth floor? The type 4 has the most largest overall force bending moment. So we concluded that type 4 structure distributes the load the most evenly. In the future, first, we will experiment more finely for the model 4, which was found to distribute the load the most in this study. We also plan computer simulation based on a function that expresses the shaking. Currently, it costs a lot of money to make earthquake-resistant buildings. So, if a little ingenuity such as our idea can increase earthquake resistance, even if only slightly, it will make it possible to build earthquake-resistant buildings at a lower price. These are references. Thank you for listening.
Thank you for the helpful presentation. Does anyone have any question?
Yeah.
Yeah, and then you find the most bending scene. Right?
Most bending.
I want to know that how you recreate the scene. That you thought that you recreate the scene. That how you reproduce that scene.
Thank you for your question. We played the video one frame at a time and picked up the scene of maximum displacement. Okay.
Yeah, that I want to know how you know that maximum distance is how you measure that maximum distance.
The scene, it means the maximum displacement of the top floor. Okay.
So did you measure it in centimeter or?
Yeah. Centimeter. We measure the centimeter.
Because you look at the clip, right?
Yeah.
Yeah, I want to know that how you measure it on the clip.
The width of the first floor is 5 centimeter. So we measure the displacement of top floor by this ratio.
Comparing ratio.
Yeah. Okay. Thank you for the question.
Are you the first group to present that the building with different height in each story
Yeah.
will withstand the vibration. Is there any publication mentioning about like we should vary the height of each story like this? Like, is there anybody working like this idea, but on the concrete structure or something else? Because in the real situation, we need the story with the same height, right? So that we have good distribution of spacing. If we do different height like this, some people on the floor that has a lower ceiling, they may suffocate. Like it has to be very low. So, what do you think is nobody working on this concept in the concrete structure before? Concrete?
Yeah.
No. No. So you can present this in the NHK channel. It's worth showing your work there.
I have one question about your experiment.
Yeah.
What is the frequency of your shaking?
Yeah.
In your experiment, what is the frequency?
It is 2.56 per second.
Not kilohertz, just hertz. 2.5.
2.56 per second.
Per second.
Yeah.
Does the frequency have effect on the structure?
Yeah.
Yes. If we change the frequency, what is going on the structure?
We think if we vary the frequency in this experiment, we think the value of bending moment is change the each model. So this graph is change a lot, and so we consider this ratio. Yeah. Okay, thank you.
The selected frequency here is equivalent to how much Richter. Normally when we talk about earthquake, we report it in Richter. Yeah. The strongest one is like 10 Richter. For this one, how much is it in Richter?
Richter. What is Richter? I'm sorry.
It's a unit like a... The earthquake itself has the number to represent the strength of it too. The strongest earthquake is 10, like that. So in this frequency, how strong is it? Is it strong enough to crumble down the structure?
Yeah, it is enough.
How much is it needed? It should be 5. What is the number of the strength of the quake?
I don't know how number. Yeah. Thank you. Thank you very much.
It cannot refer to the strength of earthquake.
Thank you very much for advice.
Thank you, the commentator and the audience. Now, may I invite Assistant Professor Dr. Apishok Tangtakan to award the certificate to the presenter from Hiroshima University High School. The next presenter are from Princess Chulaporn Science High School, Trang, with the project entitled The Electric Physical Therapy Bike.
We not chat of the presentation.
Good morning, everyone. We are from Princess Chulaporn Science High School, Trang. Today, we would like to present our project named The Electric Physical Therapy Bike by me, Patira Shushui, and this is Tirana Sekau. To begin with, we're going to start with the statements and significance of this study. Nowadays, in our society, there are numerous people with ALS, myotrophic lateral sclerosis, that normally called the muscular weakness dystrophy, especially in Thailand and in Dolly. The treatments that make patients have recover from the disease are physical therapy or strength training. This is why we came up with this new idea and want to create it to make patients have a better result.
The purpose of the project is to invent the bicycle for physical therapy and muscle training for ALS patients to test the efficiency of the physical therapy electric bicycle and to recycle some material and invent useful equipment that can be used. Hypothesis and the scope of the study is to develop the bicycle to become more efficient and strengthen ALS patients' arm muscle and leg muscle.
These are the materials and tools. For experimental method, we divide it into 3 sub-steps. First sub-step is sketch design. This is our sketching. Next is the methods of operation.
And the last step is experimenting with the patients. Step 1, record the personal information of the participants. Step 2, record the level of arm muscle strength and leg muscle strength before the experiment.
For arm muscle strength, we measure by a hand grip dynamometer. The patient will hold the hand grip dynamometer and then squeeze as much as possible and release. The result will come out in kilogram that we could compare to the table here. And for leg muscle strength, we contact a physiotherapist to measure the leg muscle strength for us. But the principle is that the patient will exert and the physiotherapist will resist them. If the patient can resist the medical force, it has 6 levels on the table here.
Then use the bicycle for 3 times per week and in the 3 sets of 5 minutes each for 4 weeks. After 4 weeks, record the level of arm muscle and leg muscle strength after the experiment. And lastly, the participants evaluate the electric physical therapy bicycle survey.
For instruction, first sit on a bicycle, plug in the power supply, and then turn on the switch and adjust the speed that suits each patient. Our bicycle has a lockable wheel that can be used anywhere and easy to move, and also the CCTV camera that can be linked to the caretaker phones. The reason why we use the motor here because our purpose is for ALS patients that don't have enough force to do a normal bicycle. So we use motor to reducing their force and assisting the physical therapist for them. Overall operation, table 1. The table shows the level of arm muscle strength before and after the experiment for left side arm and right side arm of 10 experimenters. We have the column of value chain to see the development of the muscle strength. And for table 1, the summary table shows the number of people with arm muscle strength has value increase. For left side arm has 9 people and for right side arm has 10 people. Table 2, the table shows the level of leg muscle strength before and after the experiment, same to table 1, but the information will be in form of level. We also have the value change to see that increasing as well. From table 2, the number of people with leg muscle strength has results increase. For left side leg has 8 people and for right side leg has 8 people as well. Table 3, the table shows the results of satisfaction evaluated after using the electric physical therapy bike. From out of sight, we got very satisfied.
Conclusion: the efficient electric physical therapy bicycle helped patients strengthen their arms and legs, and the participants were very satisfied with the experiment.
And this is the end. Thank you for your attention.
Thank you for the innovative presentation. And does anyone have any question? And may I invite our commentator to give some comment and suggestion to the presenter, please?
Okay. Could you explain me about the measurement of the muscle? If the muscle on the leg, you use the electric bicycle to adjust the frequency of the rotation to make a therapy. Okay, and how to measure the effect of the therapy to the leg? How to measure it?
So we contact a physiotherapist to measure it for us, because now in Thailand we don't have equipment to measure that in like specific. So we asked the doctor in the physiotherapist that work with this how they could know he get better or they get better. So he tell us that he will the patient will exist and the physiotherapist will resist them. If the patient can resist that force, it will be 6th level of the. Yeah.
How long is the exercise?
So we use the bicycle
3 times per week.
Yes.
This is a standard number.
They doesn't have a standard number, but we talk with them and decide to choose the best time, because if it's too long, it will get effect for the symptom. So this is yeah.
So is there anything new about the structure of this bicycle?
Yeah.
Which part is new that you add and is different from the commercialized product?
So we studied commercial product in like the market, and it has two types. First, it's just a normal bicycle that everyone can use it, and the second type is for physical therapy. But the physical therapy one, it's only for arm or only for leg. Don't have like both of them. And for the normal bicycle, they cannot use it because they don't have enough force to do that. So we want to make the one that they can do both of them and can do it. Yeah.
Okay. Are you sure that
Yeah.
nobody has a product that work on two groups of these muscles? I think I saw some, but it may be different from yours. You should look it up. Like nobody really working on these aspects. Okay.
Yeah.
Yeah. How much is this bicycle?
We think it's around 2,700 baht. Because now in the market is around 4,000 to 5,000 and up to that.
Is there any danger part that can harm the patient?
Yeah, we think about it a lot and we want to develop it more, like to make a sensor that if they lost their control or out of the bicycle, it can be stopped and it can be more highly secure for them.
So it's like the patient do the speedy thing and he cannot stop.
Yeah.
Really?
So but we want to like have a sensor to, yeah.
Maybe it's a bit too.
Yeah. We can adjust the speed. Yeah. No, we use like, how to call it? We use a recycled things to make it.
Normally when we did the design, we have to add some calculations
Yeah.
to show some physics calculation.
Yeah.
What do you think it should be? Which part that need calculation specifically?
About the circle, when we write it, we want to study more physical way that can affect to the patient. Like study in more the speed that suit age level of patient. Yeah.
Thank you for your presentation.
Thank you, the commentator. And may I invite Assistant Professor Dr. Nuwat Pimpabut to award the certificate to the presenter from Princess Chulaporn Science High School, Tang. So, I would like to inform that it's because National Institute of Technology, Kosen Suroka College cannot go in the presentation. So you can take a break for 15 minutes. You can relax and go to toilet. The next presentation group will start at 11:45 a.m. model rocket using an autonomously controlled wings.
Good morning, ladies and gentlemen. I am Netiton Kamali, and this is my partner Chayutpong Pibun. Today we will talk about my project in research and development of autonomously controlled wings for reusable solid fuel model rocket. So to start off, I think everyone knows this. This is the SpaceX Falcon 9 rocket, which can land itself after completing a journey to space. Now, the problem is this rocket uses a liquid fuel rocket, but solid fuel rockets such as the side stage of the SLS rocket of NASA still don't have a system implementing it to be reusable. So in this project, we aim to study into how we could make a rocket, a solid rocket reusable.
Okay, so starting off by our flight plan, I will do the quick by this. This is our flight plan. We first launch the rocket and then we do the stage separation. And after our rocket reached apogee, we will deploy the recovery wings. And then we will use the control surface to glide our rocket back. This is the summary of our flight plan. As you can see, after our rocket flips off, it will do the flip maneuver and deploy the guide wing. And this is where our rocket takes place, the gliding phase.
All right, now we will set the initial condition for our study. So this is a theoretical study of how our rocket will perform in a two-dimensional space. So the problem with a rocket is that when we launch, the launch trajectory will make the rocket fly with a distance from the launch site. This is bad, and we want to eliminate this problem such that the rocket can fly back to the launch site using our system. And the theoretical maximum wind rush-off distance simulated with our program, which is an open rocket, is 460 meters with the apogee of around 500 meters. And if this is how we will measure the efficiency of the rocket. If the target, the maximum target range is the target that we want to fly back is within the maximum target range, it would mean that our rocket will be able to glide itself back into the target that we want, which is the launch site.
Okay, so to sum up, in these studies, our objective is we want to stabilize and control the rocket back as close as possible to our base. And we want to study different types of fins design and compare their efficiency. Okay, moving on to the most important part of our studies, the airfoil selection. After we know that we want to build the wings to glide our rocket back, we start off by selecting the airfoil shape. And from many airfoil shapes that we have commonly used, we do the comparison between CL and CD ratio and the angle of attack, and we choose the two best performance of our airfoil shapes. And as the result show, we got the SD7037 and the E201 airfoil shape to compare. And we also choose the one standard asymmetric airfoil with the best peak performance, which is NACA 0010 to do the comparison.
Noted, this is symmetric as airfoil. I just put in the wrong thing. Next.
Okay, next. After we know that we want what shape airfoil we want to use, we will model the 3D model and we scale it same size as we want to use with our rocket. And we decided accordingly to our selected airfoil, and we model it to use in finite element further.
Now moving on to the finite element analysis side of the project. This is the study parameters of our simulation, and then the right side is the picture of our simulation setup. We have the inlet in the front, and then we have the airfoil in the middle. This is done in 3-dimensional, but the cross-section of the study is in 2-dimensional. And this is the finite element analysis equation that we use inside the model. Now, after we've done the calculation, we have varied the air velocity of the air coming into the simulation in different type of airfoil, and we got that this is the result. As we could see that this is the result at each velocity, and we can then predict at any velocity how the airfoil will perform using the data, and then we plot the graph and then we compare it.
Okay, so next, we want to predict that if we use these wings and these wings, how far that our rocket can go. So we first off use the data that we got from the finite elemental before. We use the lift and drag data that generated at different air velocities and then we plot that data into Microsoft Excel, and we create the lift of air velocity equation to, like, if we want to know that how many lift will generated at a certain speed. So we combine that equation to the data from our flight profile from OpenRocket, and then we calculated the lift that generated at the wings in every moment of our rocket when our rocket is descending. So after we know that, we know every lift is generated on every moment of our rocket, we will calculate the acceleration that happened to our rocket using the Newton's equation given mass to 1.7 kilogram. And after we got the acceleration data in every moment of our rocket, we plot that data into the Microsoft Excel to create the acceleration of time equation. And then we use the calculus to calculate the S of t functions. And we sum it up, integrate it up to calculate the maximum distance that our rocket can fly within the range.
Now, with all the results, we have simulated these on 3 of the airfoils and found that the NACA 001 airfoil is the best performing airfoil in that it can produce a distance maximum displacement of around 600 meters. And then we have used this airfoil to then make a glide ratio prediction, and then we have predicted the glide ratio to be around 0.67, which for coming back to the first point we made, that the maximum wind wash-off distance is 460 meters. Our airfoil are able to be used in this scenario and then completed the journey accordingly. So this is our end of our project. Thank you.
Thank you for the excellent presentation. And does anyone have any question?
Yes. 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 Yeah, on the side stage.
But for me, I'm not clear what is solid. For example, if Elon Musk use a solid fuel, why solid fuel can make like a reason trick like this?
Well, the liquid fuel model rocket, the liquid fuel rockets of Elon Musk use a on and off base approach. After it reaches the apogee, it will burn the rocket again so that it would fly back using thrust from the rocket. But in my scenario, I am trying to solve a problem that is the NASA rocket is not reusable in any way, shape, or form, and they are using a solid rocket which are expandable, and we want that to come back and then we can use it again so that we would reduce the cost like the Falcon 9 rocket. So to conclude, it is for rockets, currently rocket, an add-on system to our current rocket, which is a solid rocket, but to be able to make it fly back close as possible to Elon Musk's Falcon 9 rocket. But our method uses glidable wings instead of thrust.
Okay. Did you calculate the condition in 3 dimensions?
The condition of the finite element analysis is in three-dimensional, but the calculation of physics that the maximum maximum glide distance is in two-dimensional, because in three-dimensional there are many more factors that are not accounted for in the 2D dimensional. The prediction of the Open Rocket software is in two-dimensional, so our simulation also is in two-dimensional.
How important is the center of gravity of the rocket compared to the shape of the airfoil?
Very important, because the center of gravity and the center of pressure define how the rocket will behave in each situation and how easily it will be able to maneuver around the point that you are going to want it to be. So, very important. But our design accounted for that and placed the airfoil in effective position that it is able to glide back without rolling over or flipping over. It is in the center of pressure is well behind the center of gravity.
Did you have that result about the rolling over prevention that you successfully achieved with the design? Did you show that in your presentation or had that?
No, because it's a preliminary design that have to be accounted for in the first place. Because if you design a glider with a center of pressure in front of the center of mass in the first place, it wouldn't be able to fly in the first place. So yeah, we didn't have to include that.
Normally, is there a common or conventional airfoil that they used in this kind of rocket?
We have tested these airfoils that is conventional in gliders, but mostly in rockets we doesn't have to account for the performance of the gliding, because rockets being rockets, we just have to propel it to the point that it was needed to be. Any more questions?
Thank you, the commentator and the audience. Now, may I invite Assistant Professor Dr. Nuwat Pimpabut to award the certificate to the presenter from Princess Chulaporn Science High School, Nakhon Si Thammarat, please. Now, I would like to inform you that about science activity, we have an appointment at 3:30 p.m. in front of canteen. Well, ladies and gentlemen, we've come to the end of the morning session. Thank you to our presenter, honorable commentator, and participants. And now may I invite everyone in front of room to take group photo, please. Welcome to the presentation room of Thailand Japan Student Science Fair 2023. My name is Walintana Suriwong.
And my name is Wachirawan Aphinyano-Rangsi.
We are the students from Princess Chulaphorn Science High School, Loi, your moderator this afternoon. You are with us in the Smart Classroom 2202, scheduled for the presentation under the theme of physics. We would like to welcome you all to this 13th oral presentation. First of all, we would like to introduce our commentator. The first commentator is Assistant Professor Dr. Apishok Tangtakan from Department of Physics, Faculty of Science and Khon Kaen University. And second commentator is Assistant Professor Dr. Nuwat Pimpabut from Department of Physics, Faculty of Science and Technology, Loi Ratchapat University. And we are also glad to introduce three schools that we will be joining this oral presentation. Chiang Rai, please raise your hand, please. Princess Chulaphorn Science High School, Satoon. And Bun Kiao Gakuin University Girl High School. Today's session is being recorded for viewing as post-conference. Therefore, you can watch the recording later on TJSSF 2023 channel. And please check the time to begin the section. We would like to explain the guideline of each presentation. The time of each presentation is 15 minutes, 1 minute for the preparation, 7 minutes for the presentation, and 5 minutes for comment and discussion, 2 minutes for certificate and take photos. And please check the time shown on monitor. When you see this sign, it means there is 1 minute left. And when you see this sign, it means you should stop because the time is up. Today, you will receive only a cover of certificate, and you can download the certificate on TJSSF 2023 website. We apologize for your inconvenience. During the presentation, please switch off your mobile phone. If you want to take photos, then please stay in your seat and refrain from walking around. Be mindful of the audience. So, first group will start presentation at 1:30 p.m. So you can go to toilet and relax now. first group from Princess Chulaporn Science High School, Chiang Rai. Today they are going to present their project entitled Comparison Performance of Cushioning from Bagasse Extracted Wet Alkali. Ladies and gentlemen, I will now turn the session over to our presenter. Please give them a round of applause.
Test. Good afternoon, Professor and everyone. Today we're going to present about our project named is Comparison Performance of Cushioning from Bagasse Extract with Alkali. My name is Thanyaporn Norarat.
And my name is Nathalida Sakun.
Let's start with introduction. Plastic waste accumulation is a problem that had been allowed for a long time as the material that is widely used, in which the transportation used plastic cushioning to protect the packet from damage, which causes the problem of accumulating plastic waste because plastic is difficult to decompose, and the problem of bagasse left over from sugar production, which is an agricultural residue from the sugar industry. From past research, bagasse fiber were separated from sodium hydroxide to apply as a better using sodium hydroxide. Therefore, we was interested in doing the buffer is made from bagasse extract with ash water, which has similar strong base properties, even though ash water has less complex and natural production process to create cushioning that are safe for the environment, reducing the problem of waste bagasse and using waste material for maximum benefit. About objective. First, to create biodegradable cushioning material, and second, to test the protective ability of the cushioning. Experiment. Our overview have 3 steps. Step 1, separation of fiber by use sodium hydroxide and ash water. Step 2, forming a sheet. And step 3, physical test.
Step 1. Separate off fiber. First, we prepare bagasse. Then, mix sodium hydroxide concentrate 10% with mixed ash water and boil 100 Celsius for 6 hours. And finally, blend it. Step 2. Forming a sheet. We coat with concentrate 100% paralabster. Put fiber into the mold and bake at 100 Celsius for 15 minutes. Step 3. Physical test. We have 3 tests. Water absorption. We calculate by dividing the dye weight by the water weight after 5 minutes and multiply by 100. Strength test. Test by pull until beyond the tear. Then measure the strength in leg and tensile force, then calculate. And tensile strength test and elongation, we use a pendulum to weight the shock proof, then convert the weight of the pendulum to the force used. Result and discussion. In this horizontal line is shockproof type is sugar cane bagasse extract with sodium hydroxide, sugar cane bagasse extract with ash water, and shockproof plastic. In the vertical line is water absorption, state, and tensile strength and elongation. We use shockproof plastic as a prototype to compare with cushioning extract from sodium hydroxide and ash water. This is picture of result. Picture 1 is bagasse extract from sodium hydroxide, and picture 2 is bagasse extract from ash water. For the result of the study, water absorption value of the cushioning extract from ash water is similar and less than that extract from sodium hydroxide, while strength and tensile strength and elongation ash water is higher. The cushioning from bagasse extract from ash water has a state value of 0.384 and a shear strength of 54.75 Newton, which had properties similar to plastic cushioning than those extract from sodium hydroxide, including having a low water absorption value of 48.32%. Therefore, flexibility impact less resistant and protecting the material. This is all of our project. Thank you for your attention.
Thank you for the inspiring presentation. Does anyone have any question? And now may I invite our commentator to give some comment and suggestion to the presenter, please.
What the size of your sample size?
We use 30 centimeter.
Do you have a picture of it? Accepted from two conditions from the sodium hydroxide and ash water. What ash water? Ash form.
Is from ash.
What kind of ash? From coconut, from wood, from
Wood? Yes. Oh. It's scrap wood. Yes.
So from this ash, you will also get the sodium hydroxide, right?
We use 10 gram of ash and mix with the water 1 liter. We use add water because it is a strong base like sodium hydroxide. Yes, and the ash water have 11, 10 to 11. Yes, and sodium hydroxide is 12. Yes. Yes. Sorry, where?
Good afternoon, everyone. Today we will present our project, Totally Calculate Association.
What is the reason behind the big difference between the two?
I think the finally fiber that we have. Yes, and yes, I think
The
about the
stronger
fiber.
fiber weaken.
Yes.
And the stronger pH weaken the fibers more.
Yes.
So did you have a picture to show that? What is the change in the morphology of the fiber before and after etching with sodium hydroxide?
We don't have. Sorry.
Okay. It's okay. Yeah. So in the table, the name is shock proof. Shock proof normally represent the impact test only. Okay, we need to modify the word. Impact test means dropping the weight onto the material. It's different than the stress the tensile strength test. Dynamic test is different from static test. Yeah, but good.
Thank you.
Thank you, the commentator. And now may I invite Assistant Professor Dr. Apishok Tamtakan to award the certificate to the presenter from Princess Chulaporn Science High School, Chiang Rai. And please give us a moment to fix a problem. The next presenter are from Princess Chulaporn Science High School student with the project entitled The Efficiency of the Fertilizer Spreader in the Rubber Plantation in Songkhla Province. Please welcome.
Good afternoon, honorable judges and everyone here. My name is Natanan Sudrak. And my name is Julalat Lawson. We are representative from Princess Chulaporn Science High School student. Today we're gonna present about our project, the efficiency of the fertilizer spreader in the rubber plantation in Songkhla Province. First, let's talk about the introduction of our project. This project originated from inventors' inspiration, so my family has a rubber plantation of more than 16,000 square meters, and every year we have to fertilize the rubber. So the way that my mother fertilized the rubber is she put 10 to 12 kilograms of fertilizer in a blanket, and then she walked and sold all of 16,000 square meters. And I used to help her sow fertilizer, and then I totally understand that her back hurt and her wrist hurt a lot. Fortunately, my father is an engineer, so together we came up with a way to make it easier for my mother to sow the fertilizer. We thought for a long time, and then my father said that there was a card that was not used at home. Shall we try to adapt it? And I went looking for many information about the fertilizer spreader, so I found that the Kubota FS200 fertilizer spreader, and then we adapted the model of the Kubota FS200 fertilizer spreader to our car, so it was the origin of this project. Our project have two objectives. Follow this page. First, to study and test the performance of the fertilizer spreader inventor decided. And for objective 2 is to study the performance of the fertilizer spreader with the difference of a number of views to compare when with one view and when with 3 views. So we have two methods about our project. For objective 1, we took a card and drill a hole in the middle of the card, then install the motor below the hole, and then install the battery and switch together into the motor. When we turn on the switch, the fertilizer will flow into the hole, then spread throughout the rubber plantation because there is a rotating motor at the bottom of the card. And don't be afraid that the fertilizer will flow all the time because we have a steel plate that open and close the hole. For objective 2, we increase the number of a wheel card from 1 wheel to 3 wheel fertilizer spreader because 1 wheel card, when we put it into the rubber plantation, is difficult. We have to use both lifting force and pushing force because the rubber plantation has a lot of rubber roots. But when we increase the number of wheel to a 3 wheel card, we found that we only use pushing force. Therefore, a 3 wheel fertilizer spreader will rubber saving than a 1 wheel fertilizer spreader.
Next is result and discussion. First, I will show you all about bar chart and table of objective 1. First bar chart is comparison the fertilizer spread the width and people speed for fertilizer. This bar chart will show you how different speed between people sowing fertilizer and the fertilizer spreader. We calculate speed from distance divided by time. So when we use fertilizer spreader, it's more farther than people sowing fertilizer. And first table is comparison the spreader and people for fertilizer. This table shows that when we use fertilizer spreader, it's more labor saving than people sowing fertilizer. So the result in this table we calculate by this equation. Next is bar chart and table of objective 2. From objective 2, we increase a number of views from 1 view fertilizer spreader to 3 view fertilizer spreader. So second bar chart is comparison of spreader speed with different views. And second table is comparison of spreader fault with different views. And from the result in this table, we calculate by this equation. Finally, when using 1 view fertilizer spreader is faster and help with labor saving than people sowing fertilizer. Also, if we increase a number of views from 1 view fertilizer spreader to 3 view fertilizer spreader, it will be able to go faster and labor saving than before. Thank you for listening. Hope everyone understand and enjoy our presentation.
Thank you for the helpful presentation. Does anyone have any question? Okay, and may I invite our commentator to give some comment to the presenter.
Could you tell me about the performance of your fertilizer spreader? What is the performance of it? Such as gram per minute, such as can this
When people sowing fertilizer, they use a bowl, 1 bowl. Yes. So half. Yes. Half a day. With two people. Compare with 2. Light. 16,000 square meter. Yes.
For human, two people to sowing fertilizer half a day, but fertilizer spreader one can one less than yes. Finish early than people. Sorry for this answer because we don't.
Good afternoon, everyone. We're from Princess Chulaporn Science High School, Lopburi. My name is
Thank you, the commentator. And may I invite Assistant Professor Dr. Nuwat Pimpabut to award the certificate to the presenter from Princess Chulaporn Science High School, Stone.
The next presenters are from Benkyeo Gakuin University Girls High School with the project entitled Analysis of Spectra Utilizing Spectrograph. Please welcome.
Hello, my name is Irina. I'm from Bunkyo Gakuin University Girls Senior High School, Tokyo, Japan. My experiment is about the spectra of stars and making my own DIY spectrograph to measure the light from stars. My experiment. Sorry, do you know what the sun is made of. Sorry. Do you know what the sun is made of? The sun is approximately made up 9% hydrogen and 10% helium. Each star and planet is made of various materials, and we can analyze them by studying the light they produce. A spectrograph is an optical instrument that measures the light. It can be attached to a telescope to measure the light from far away. These are the keywords in my experiment. My objective was to make a spectrograph that is simple and inexpensive, but at the same time, something that performs well. In the experiment 1, I used 3 mirrors, a collimator, and a diffraction grating, and a wooden box from 6 wood. This is a collimator, these are the mirror, and this is a diffraction grating. And my method is a 3-step. First is make a spectrograph. Second, focus with the light. Third is find the spectrogram through the camera. This is the image of my experiment 1 spectrograph. As a result, no light spectrum was reflected through the diffraction grating. Look at here. This is thought to be because the diffraction grating was transmissive type. In the next experiment is based on experiment 1. I use a collimator, a diffraction grating, that reflective type, and camera, and white light, blue light, white light, blue light, red light, and sunlight. These 3 lights, white and blue and red, was LED. I was same things to experiment 2. I was able to observe the spectra of white and red light as well as sunlight. However, the spectrum of the white light and sunlight did not show any dark lines that were needed to clearly differentiate the color spectrum. In addition, the blue light spectrum was fuzzy and diffuse, and as color as the other light color. This is my objective, so I want to talk about the cost and performance. In experiment 1, the total cost was 6,186 yen, and experiment 2, the total cost was 0 yen, because my advisor, who working at Japanese Observatory, gave me all of materials. Therefore, I can say that to make a spectrograph to low cost. As for performance, dark lines could not be seen as color spectra could not could not be confirmed, so the performance was very poor compared to the spectrograph captured at an observatory. My future experiment will concentrate on improving both instrument and methodologically to enhance the detection of the dark lines that define the spectrum of sunlight and white light. In addition, I hope to gain a better understanding of the spectra and composition of the universe by examining the spectra of various stars, especially the fast stars. My references are here. Thank you for listening.
Okay, thank you for the excellent presentations. Does anyone have any questions? Okay, next may I invite our commentator to give some comments to the presenter, please.
Did you measure your sample by using the commercial spectrometer for compare this your result?
I can't do that, but I was research the spectra of sunlight. This one is a collect sunlight to use observatory spectrograph. This is sunlight spectra.
What improvement you can do with your present work?
I think sunlight. I was measure the sunlight. When I was measure the sunlight, I can't spectrograph to darkness. So I think there is no light, no different light. So I think more darkness to spectrograph, I can't look dark lines.
What about the equipment? Can you add anything to make it more viable for measuring the spectrum? No more devices to put in your current equipment? Or just change it to something else that is more expensive, so it make it more usable?
I will cover the dark clothes and to the darkness. So I think I will that. Sorry. Thank you.
Okay, next, thank you for the commentator, and may I invite Assistant Professor Dr. Apikchok Tangtakan to award the certificate to the presenter from Bankyo Gakuin University Girls High School. Now, I would like to inform you about science activity. We have an appointment at 3:30 p.m. in front of canteen. Well, ladies and gentlemen, we come to the end of the sessions. Thank you to all presenters, honorable commentators, and participants. We hope you enjoy the remainder of the Thailand-Japan Student Science Fair 2023. And see you again at Princess Chulaporn Sen High School, Pathum Thani in next 2 years. So today we would like to say thank you very much and goodbye. And may I invite everyone to come in front of the room to take a photo, please? Come here.
Patala. Tas.
Thì nó bảo cái gì